Alrighty, last problem. Okay, so for example 5, this is a little different looking from the other ones, right? Because we don't have one that looks like that form that we were originally working with, right? So we are going to have to go to college algebra and use completing the squares. I'm not sure if you guys remember what that is, but completing the squares is this purple box right here, okay? So essentially, we need it to look like the left hand side, and then we can rewrite it as the right hand side. And if we rewrite it as the right hand side, we'll have it in a form that we can actually use on this chart, okay? Cool, so we were given this underneath the radical, so I just rewrote it from descending power. So I wrote negative x squared plus 4x plus 5, okay? Whenever you're working with completing the squares, this has to be a positive one. So I factored out a negative, okay? So I factored out the negative, so that makes it positive, negative, negative, okay? So this negative is just gonna tack on at the very, very, very end, okay? So let's just pretend like this negative isn't here right now, and then we'll tack it on later, okay? But essentially, now we're just working with this on the inside here. So our goal is to make it look like this left-hand side so we can rewrite it as the right-hand side. So we have 1x squared, perfect. Our b here is negative 4. And then over here we have negative 5. So we need to figure out what b over 2 is supposed to equal. Is it supposed to be negative 5? So we know that b is equal to negative 4. So b over 2, which is this inside portion right here, is negative 2. Now, if we were to square that, we get 4. So, let me see. So, this black box right here is supposed to be this, right? We figured out that b over 2 squared is 4. But it's negative 5. So we need to figure out how to change it to 4. So remember, if you add something, you have to subtract it. If you multiply something, you have to divide it. So essentially, if we make this negative 5 a 4, that means we're going to have to add 5 to get to 0. And then we're going to have to add 4 more to get to 4. So essentially, we're going to add 9 to get our plus 4. And then to reverse it, we have to subtract 9, okay? So we just brought the negative down because we can't have the negative when we're completing the squares. We have 1x squared minus 4x. Now, instead of negative 5, I'm now rewriting, this was kind of bad boxing. But anyway, I'm now rewriting negative 5 as plus 4 minus 9. Does that make sense? But I needed this 4 because that's what this black box is supposed to be. So I guess I really shouldn't have put a black box here. Sorry, I'm just trying to make it make sense. Okay? So now, yeah. So we're going to just leave this negative 9 off to the side, okay? Which means we can rewrite this portion right here as this side over here because it's in the correct form, okay? So we just bring down that negative, and now we can rewrite it as x plus b over 2. We already found b over 2 previously as negative 2, so we plug in negative 2 and then we square it. And then we just tack on that negative 9, okay? Now, to get rid of this negative, you distribute it to both of our parts. There's actually only 2 parts here. This negative right here is a sub part, right? Because it's all being squared. So essentially, it's going to be negative of this squared thing and then positive 9. So I've just switched the order, okay? So we have 9 minus this squared thing. So now all of this can be we'll change the format of the stuff underneath, okay? So now this looks like something that we can use. We have a minus sign when we have the a in the front, so we'll be using this first one. So we need to find our a first. So in this case, this 9 is a squared. So to get the a by itself, we take the square root, which will give us 3. So then our x is going to be 3 sine theta. We find our Sorry. I almost messed up there. So our A is our 3, right? And in this case, our X is not actually X. Our X is X minus 2. So now we take, instead of saying X, we're going to say X minus 2 is equal to 3 sine theta. And then we solve for our X. And then we take the derivative of our X. Remember, this is just a scalar, so we tack it on. The derivative of sine is cosine, and then numbers just go away. Alrighty, so from here, we're changing all of our x's to our thetas, and then we'll change all of our thetas, hopefully back to our x. Yeah, I think so. Alright, so, so we have 9 minus, instead of x, we are now going to write 3 sine plus 2. Yep. So now instead of x, we're going to write 3 sine plus 2. Sorry, I see that I was skipping steps when I was working this. The reason why there's not a plus 2 is because this negative 2 and this 2 will cancel each other out. Y'all see that? Yeah, or essentially, instead of solving for x, you could have just said x minus 2 is equal to 3 sine. That's probably what I did, okay? So we square that, and then dx is now 3 cosine d theta. Alrighty, again, pluses and minuses separate your parts. Our goal is to get this sine by itself. We have that 9, so we'll factor out a 9 here, and then we split that up. We have the square root of 9, and then the square root of this red part. The square root of 9 is 3, and then using our little rule, we have 1 minus sine squared equal to cosine squared. So that means we can rewrite this as cosine squared. We have a 3 and a 3, which is 9. It's just in scalar, so we bring it to the outside. The square root and a squared cancel out, so we're left with just a cosine, but we already have a cosine, so that gives us cosine squared. And then we go back again to section 7.2. I've actually written it out right here. So we know that cosine squared theta is the same thing as a half, which is where this 2 on the bottom came from. And then 1 plus the double angle of cosine. Whenever you're adding and you're working with, brain fart, antiderivative, you can split it up, right? So I did 9 over 2 integral of 1 here, and then plus 9 over 2 integral of the double angle here, okay? If it's just a number, we're just left with our theta, and then we still have that 9 over 2. And then here, we're doing the integral of trig. We have cosine. Remember, we work backwards. So the derivative of sine, so since it's cosine, we know it's going to be sine. So the derivative of sine is cosine. It's positive, so we're good. And then the chain rule here would tell us a 2 if we're taking the derivative, but we're doing the antiderivative, so we have to divide by 2. So that's the reverse chain rule, or whatever you want to call it, okay? And then we say our plus c, because we're not evaluating it from anything. We can simplify this a bit. That's going to give us 9 over 4. And then we need to go back to our trig identities for double angles. We know that sine 2 theta is equal to 2 sine theta cosine theta. So now instead of this, I have written this. And the only reason why I have changed it from the double angles to single angles is because our goal is to write it in terms of x, right? And if you have a double angle, you have to solve it differently. That'd be a whole nother trig lesson. So it'd just be simpler just to change your double angles to single angles, okay? And then we go back to our trig SOHCAHTOA, figure out how to find sine and cosine using our triangle, okay? So we're going from theta back to sine, back to x. So we look up and figure out where x and theta are in the same equation, and we can use this right here. So x is equal to 3 cosine, or x is equal to 3 sine plus 3. Right, so we subtract the 2, and then we divide by 3 to get the sine by itself. I don't really know. I feel like there's a reason why I did this, but let me just take this off right now. So, yeah, essentially we have this, right? So we have sine, which is SOHCAHTOA. That's opposite over adjacent. Our opposite is x minus 2, and our hypotenuse is going to be our 3. To find our other leg, we use the quadratic formula, and we get this down here. Can y'all see that? No, you can't. Sorry. Okay, yeah, so again, just ignore this for right now. I don't really remember why I did that. We might not need it. But yeah, essentially we have our sine, opposite over adjacent, find our other leg, okay? Alrighty, so we have, oh, that's why we had to do it. Okay, y'all see up here how it says 9 over 2 times theta? We had to solve for theta, okay? So yeah, our theta is sine inverse of x minus 2 over 3, okay? So that's where that came from. So instead of theta, we're now going to rewrite it as this. Then we have plus 9 over 2. Our sine is opposite over hypotenuse, which is going to be x minus 2 over 3. And then times our cosine, which is adjacent, which is this red part, which is where this came from, over our hypotenuse, which is 3. Okay? We'll do some simplifying. Pluses and minuses separate your parts. So this is all one part because they're all connected by multiplication. There's a 9 on the top, and there's actually a 9 on the bottom with those 3's, right? So those cancel out. And then we're left with the final answer.